Everybody, welcome back to another fun and exciting geometry class. Today we'll be in lessons 5.3 and 5.4. Those are found on page 238 and 239. And we're going to be talking about a couple different things. Really, it's an extension of the last lesson. We'll be talking about the area of a parallelogram and then also the area of a triangle. So let's go ahead and get into it. Area of a parallelogram is PL, so capital letter P, small letter L, and then that equals BH. And maybe you're like, wait a second, I thought yesterday's lesson was BH. Well, good news, you're right, you haven't lost your mind. Theorem 69 says the area of a parallelogram is equal to the product of its base and its altitude. The parallelogram theorem and corollaries are the same as the rectangle. So in other words, what we learned in last lesson applies to this lesson as well. But I do write down here, be careful to remember that the slant height and the height are two different things. So here's our parallelogram, and our parallelogram is this purple shape right here. Well, our height is this right here. The distance from the base to the second base, we call that base 1, base 2, or from the bottom to the top, okay? Now, if you look out here, check out this little piece right here, right? What is this? It's this piece right here. So if you take this piece and you flip it around, it fits into that spot. What happens when we fit that piece into that spot is we end up with a rectangle. So basically this piece flipped over here makes this a rectangle. So a parallelogram is really just a rectangle that's like off-centered, okay? So once you center it back up, once you square this up, once you make these 90-degree angles, right? So that's a 90-degree angle, that's a 90-degree angle. Once you do that, it ends up being the same exact formula. This is the important thing. This is not the height, okay? This is what's called the slant height. This is the height. The distance from the top to the bottom in a straight line. In other words, this has to be a 90-degree angle right here. This is not a 90-degree angle. So don't use the outside slant height. Make sure that you use this height right here. Now, they might try to throw some tricks at you here. They might actually not give you the height. They might give you the slant height. Like, let's say that they give you something like, this is 14 inches, and this is 7 inches, and then this piece right here, let's say that they give you that piece, is 3 inches. Well, they might not give you the slant height right here, but you can solve this. Don't lose your mind, okay? You'll be fine. Use what you know about geometry to go ahead and solve this. Look what we have right here. We have a right triangle. And what do we know about right triangles? We know that a squared plus b squared equals c squared. So if this is our right angle, this is going to be our c. So we could call this our a, and this could be our b. And so we would just plug into Pythagorean's theorem, and it would tell us what our height is. I won't take the time to go through the whole thing, but basically it would just look like this. You could get b by itself by subtracting a squared from both sides and end up with b squared equals 7 squared plus a squared, which is 3 squared. Okay? And then you're going to get b squared equals 49 plus 9, or b squared is going to equal 58. Then you would take the square root of both sides. I'm not going to take the time to go ahead and reduce that out. Maybe I should. You know what? I'll just do it. So that way we're kind of refreshing everything that we know. So b equals the square root of 58. 58 doesn't have a square root, so we could write the square root of 58 in there, but we really need to see if there's any square factors in 58 that we can reduce out. What are the square factors? 4, 9, 16, 25. All right, so you're going to say, does 25 go into 58? The answer would be no. Does 16 go into 58? I don't think so. So no. Let's see, not no. Does 4 go into 58? Actually, it does not. So we can't reduce that one out. So the answer would actually be the square root of 58 is going to be our height. So in this case, the height would be square root of 58. So your formula would look like the PL, capital PL, because this is a parallelogram, it equals base times height. So our base is 14 right there, and our height is square root of 58. That's how you would figure out the area for that. Plug it into your calculator, whatever it gives you, that would be your answer. A lot of times that the problems that you get are going to be a little easier than that. They're not going to have square root of 58 in them, but they might come out to a whole number. They might come out to a square root that you can solve, something like that. This one does not. You would just multiply those together, but it would give you the area of that parallelogram. All right, next is the area of a triangle. So basically the same thing is going on. Here's that BH again, right? Here's triangle equals, or the area of a triangle, that capital T, equals base times height divided by 2. Base times height divided by 2. All right, so if we scroll down here and look at theorem number 70, it says the area of a triangle is equal to half the product of its base and its altitude. So there it is. The triangle equals base and altitude, base times height, divided by 2. Now your book puts it a little bit differently. I think the book ends up saying that it's 1/2 BH. If you want to write it like that, it's fine. I'm just telling you this is going to be a lot easier for you as you're solving it. Base times height divided by 2. This times 1/2 can get a little bit confusing, because what is times 1/2? Times 1/2 is exactly the same as dividing by 2. So it just tends to be a little bit easier, cleaner when you're doing your work to just divide by 2. And you can divide anything by 2. You can divide the base by 2, you can divide the height by 2, or you can divide the total by 2. Any way that you do that, you will get the same answer. I put a little note here. The triangle theorem is the same as the rectangle, but cut in half. Corollaries all end up pretty much being the same. All right, so here is our triangle, right? So our triangle is this purple part right here. Now I've drawn some auxiliary lines in there dotted so you can kind of see what happens. Look at this pink figure. What's happening right here is we end up with a what? We end up with a parallelogram in this case. Remember what we just said about the parallelogram. If we straighten it out, it becomes a rectangle. So if you will look at this way, so here is half of our rectangle. So if that's our rectangle, this purple half is the triangle that we're trying to solve for. So when we find this, look at what we need. So here's what we need. We need, remember our formula, so base times height divided by 2. So we need the base. We need this right here. So let's say that the base is 10, okay? And then we need this right here. We need this figure right up in here. Now, as we keep going in geometry, they're going to make you figure things out, because if you look right here, we have another set of right angles. So maybe they'll give you something like, they'll give you the slant height again. They'll give you this side, and they'll say, okay, this side is 7. And then they'll say, maybe that this up here is something. So they'll give you like different pieces and parts of it, and then you will have to figure out the missing pieces to that. Same thing with the parallelogram. They like to do that to you so that you're having to figure things out about it. But the corollaries are all the same. They're all basically in ratio to, or in proportion to, the altitude, to the sides. All those areas are in proportion to each other. All right, so let's talk about this, and then we'll be done with this lesson. The algebra connection. What's going on here? And we already did one of these kind of up here where we're using our algebra. Maybe you were like, oh yeah, I remember that Pythagorean theorem from algebra class. Exactly. So we're going to use algebra, and we're going to find things. We're going to find missing pieces and missing parts. So here we have a problem right here, and it says the ratio between the base and the altitude of a triangle is 3 to 4. So we could put the base over the altitude. Okay, and that's, well, there we go. And that is 3 to 4. Okay, so in other words, that's a proportion. So those two things are equal to each other. Now, whenever we're solving an algebra, we can't use B and H, right? Because we only can use one variable. We can't solve it if we have a B and an H. So the way that you would solve these is you would say that, okay, so my ratio, my missing thing, let's just call it X. So the base would be 3X and the height would be 4X. Okay? So again, this is in proportion to each other. This is in ratio to each other. So now this is, this right here ends up being our base, and this down here ends up being our height. So now if we plug that into our formula, we get triangle area equals base. We said this is the base, so our 3x is our base, times our height. We said our 4x is our height, and that's all going to be divided by 2. Okay, now if you look, it says right here, it gives us the information. It says that our area is 54 inches. So we can come down here, instead of t, we can actually put 54 inches squared. And now what we want to do is we just want to use our algebra, and we want to solve this. So 54, I'll leave this off for now. We'll come back to that at the end, equals 3x times 4x. In fact, let's just do that. 3x times 4x is 12x squared. Don't forget that you're multiplying x times x. And when you do that, you get x squared over 2. Because that's one of those things that if you've been out of algebra for a while, you might make that mistake. Just because you've been doing geometry for almost a whole year. So 3x times 4x is not 12x, it's 12x squared. So make sure that you do multiply those x's together. And now what we want to do is we can actually just cancel that, and we would get 54 equals 6x squared. We would divide both of these by 6, okay? And we would get 9 equals x squared. You remember how to do this? We're going to take the square root of both sides, and we're going to get 3 equals x. Now, technically, we get plus minus 3 equals x. So let's talk about that in geometry. In geometry, you cannot have a side. So that if this is our triangle right here, you can't have a side that is, this can't be negative 3. That doesn't work. You can't have there's no such thing as negative 3 in geometry. Now, crazy enough, okay, don't lose your mind here, but there is such a thing as negative 3 in trigonometry and in pre-calculus. When we get there, when we're on a Cartesian plane, when we're graphing this, okay, we can go negative on the Cartesian plane. So there is a way to get negatives, but for what we're doing, we don't need the negative value. We just need the positive value. So this would be, a positive 3 would be the what's going on here. So just kind of exclude that negative answer. Yes, you do get a negative answer with it. We will use that later when we get to trig and when we get to pre-calculus. All right, so what we want to remember is that we did not get, this 3 is not our base or our height. It's our x. It's like our multiplier. So we need to come back up here, and we need to take our 3 and say 3 times 3. So that's the base. So base equals 3 times 3, and height equals 3 times 4. So this one is going to give us 9, so the base is going to equal 9, and this one's going to give us 12. The height is going to equal 12. So going back up here, that's what it asks us for. It asks us for the altitude, the base and altitude of the triangle. So we got it right. Now you could check it, and so you could say 9 times 12 divided by 2. So 9 times 12 is going to be 108. Divided by 2 is going to be 54. So back to where we were, there's 54 is our correct answer. So sometimes it's going to give you, it's going to ask you for a missing side, a missing piece of information. When it does, go back to algebra. When you go back to your algebra brain, okay, you can figure this stuff out. If you just stay in geometry and you're trying to, okay, what's going on here, you're going to miss it because there's a lot of stuff here in this chapter, chapter 5. There's a lot of stuff that's algebra based. You're going to have to do this, do that, and you're actually now going to be coming out with numbers, right? Geometry, we've been working in proofs and we've been working in a lot of different theorems and corollaries and things that haven't really given us answers per se. They've given us kind of more questions, if you will, and they've given us proofs. But now, in this section, we're actually going to get an answer. We're actually going to get answers like 9 and 12 and square root of 54 and things like that. All right, well, that's all I've got for you in this lesson. Hopefully you learned something there. If you missed anything, slide it back, take another look at it, and practice these. Go to those practice problems and try to figure these out, because the whole goal of geometry is to mess with your head, to try to get you to, think through things and make connections. I didn't tell you exactly how to solve all of these, but I gave you the information that you need now to take those and make connections and find those right answers. All right? That's all I got for you. Hope you have a good one. Bye-bye.